really I just, Troy asked me to come on here and talk a little bit about what we do. So I was just going to kind of talk a little bit about one or two projects that I took on since I became the survey manager for Cache Valley Electric. A little bit about me though is I've been surveying for about 11 years now. I finished school with a civil engineering and technology degree, and surveying sounded like it was going to pay the bills because there was plenty of overtime, and it's been real good to me. So I've never left. Never really thought about heading any other direction, to be honest with you. So I've worked for lots of different companies. Cache Valley, I've definitely had the longest tenure with, about 7 years. Other companies I've worked for were large civil GCs, so building bridges, roadways, high rises, airports, things like that. And then I've also worked for um, engineering firms, surveying and engineering firms, primarily one being power delivery. So their main focus is substations and transmission lines, distribution lines. So that was a lot of drone lidar work and staking out, going out and doing staking and things like that out in the middle of nowhere. Working with a lot of easements, a lot of things like that. Another company I worked for was just a small time engineering surveying firm, doing just basically all sorts of things. A lot of pre-development, so a lot of topographic mapping and things like that. But with Cache Valley Electric, I worked underneath. I worked as kind of the right hand man to the survey manager for about 5 years. Left, went somewhere else, came back, and now I'm managing the department. But one or two projects that I was kind of tasked with right off the bat when I came in to this position was these projects where we were going to need survey, but the GC was not really providing survey control. They were not hiring anyone to do it. They were not doing it internally, and where they also, the building had already been built. So what we had to go off of was a rough set of plans, and access to the building basically. So here's basically what I was given from them as far as grid lines and architectural, a little bit of structural. I think you can see these columns here as well. So this building is already built. There was no survey control inside here, and we were going to need to do layout in these three large data halls, and then we had a smaller data hall in here as well. And that's just one level. There were two levels. Each one of these rooms, you're probably looking at, I think it was 6,000 layout points we were going to need. And that was just for all of the conduit, all the electrical components. And so basically, I had to figure out how to kind of reverse survey this place, this and another place. It was the same GC, and they were both kind of what we call a fit out project, where, like I said, the building's already built, and we just need to come in and they're gonna demolish everything, install all new equipment, all new goodies and stuff in there. So basically, what we started with was right here. You see, you have this long hallway here, and that comes right around each of these data halls. So we have these long hallways here that bisect these two data halls, and then you have the two on the sides here as well. These hallways were also known as mechanical galleries. So we had a lot of HVAC equipment in there. We needed to understand where our windows for taking our conduit from these mechanical galleries and into these large data halls, where they were going to end up being, and how it was all going to fit together. So one tool that I used was the Trimble X7 scanner, much like our Yeti guys before. And what I basically just started with here, since I had nothing to go off of, was, here's a wall corner, right? Um, I'm set up there right in the middle. There's another wall corner, okay? Um, so I think I was able to shoot those and get some type of a resection with the 2 points and an accuracy within a half of an inch, which I thought was fine, because basically this point cloud data ended up just going to our VDC modelers, and they were able to, in conjunction with some other software, which I believe is called ClearLink, they were able to develop, more accurate walls and architectural and structural things. So we did scans of all these data halls, and before I did that, I set control points on, columns throughout the data halls. I set control points on these walls, and these control points were basically just sticky targets. They were just reflective little targets. You can buy about 100 of them for $20 on Amazon. And so what I would do is I would scan, and as soon as I got to one of those targets, I would do kind of more of a close-up scan, also known in kind of the LiDAR world as cooking or saturating a location. So I would do kind of just a really, really dense, really high accuracy scan. And what we ended up doing was taking the new model generated by our VDC team, and we would pick these points off of the walls, and we would turn them into control points for future layout. And then as we lined things up, we would find, we found errors, obviously, because every structural layout map is, every structural or architectural blueprint is going to show straight walls, and we all know they're not. So it took quite a bit of back and forth, figuring out how we were going to do it exactly, and what kind of tolerances we were looking at here. Took quite a lot of submittals to the GC saying, hey, just so you know, this set of columns is about 2 inches off, or and yes, some of them were that bad. And so we submitted all that stuff, gave it to them, said, okay, if you're okay with all this, we're ready to start modeling and doing our layout. And that's what we did. And it turned out to be one of the most successful projects the company's ever done. In terms of projects I've been a part of in my career, it was probably it was the least troublesome project I would say I've ever been a part of. And I'm not going to attribute it all to kind of my efforts here with the scanning, but that was definitely a big part of it. And I think a big part of it was also that we were doing a huge portion of the work as the electrical contractor on site. This was, I'm not at liberty to say who this client was or what this necessarily was, but let's just say it's one of those projects that is about 95% electrical and then 5% other trades. So we were able to kind of take this entire project and really run with it, from our own, um, with our own plans. And luckily we had a good GC that was there to support us and not really not hold us back from doing what we thought made a lot of sense. So this was one of those projects that I think was, very successful for us, for me, as manager of my department. But I use FieldLink, I use Trimble for all sorts of things, not just projects like this. We've built the Utah State Correctional Facility, out here in Utah. And that was a enormous site, and that took, we had everything all on one coordinate system, and it was about 30 something buildings, out in the middle of, the salt flats almost before you hit the salt flats, out by the Great Salt Lake. So we used a lot of VRS for that, in terms of doing underground layout and getting all of our as-builts and doing all of our layout for our underground duct banks and things like that for all of the medium voltage, setting vaults. So definitely have been using that. I've been using Trimble probably 90% of my career. I've dabbled a little bit with Leica and TopCon as well. I've been using FieldLink for my entire career here at Cache Valley. And one thing I really like about it is its interchangeability. Whereas I can, if I need to set a couple of GPS points on a site because I don't have control, I can choose exactly where I want them to be, and then I can set up my total station exactly where I planned it to be, and then I can run with that, with a certain level of accuracy. Yeah, it's just FieldLink it allows you to, and I know most other companies have something like this, but as far as I could tell, FieldLink was the first to actually allow you to basically work within a CAD file. So you can stake out exactly where if you're set up in this room here, you can stake out where that wall corner is supposed to be. You can stake out where that column is supposed to be. And a lot of times in the electrical world, we need to, especially if we're doing higher security things. I mean, it's higher security projects. The prison, for example, I would have a tiny little pocket where I would need to hit something. I would need to hit this tiny little pocket that was, maybe 2 inches wide by 2 inches long within a wall. At the time when we were building that, that was about 4 or 5 years ago. I didn't know of anything else on the market that I could do that with. And so, yeah, I have a lot of history with this program. I've been using it a long time. I really can't imagine using anything else. So, but yeah, that's really my whole presentation. I don't know how much more I can expand on that.
Thanks for that, Emmett. Let me just ask you a couple questions. When you did your scans that you were talking about in that corridor, it sounded like you were using the scanner and actually scanning known points. Sounds like maybe targets and resecting off of those targets so that your point clouds were relative to the coordinate system of those targets. Is that correct?
I'm sorry. Can you say that one more time?
Were you resecting with the scanner when you were collecting your data?
Oh yeah, yes. Sorry. So what I would do is I would use those wall corners to get a setup, and then I would set some points. Sometimes with the actually no, sorry. You know what? Now that you mention it, no. Nope. I would just simply shoot those wall corners just with the laser. on the scanner. So that's not that's I mean I would be using it as control with the scanner, but it's not. I wasn't using the total station first to set control, if that's what you're asking.
So the point clouds are just free floating point clouds relative to each other, but they
Hmm.
weren't
Yeah.
relative to the plan set itself.
No, they were. Yeah. So because I was able to use, this wall corner as a control point.
You created the point in FieldLink and then shot it
Yeah.
with the scanner. Okay.
Yep. Exactly. Yeah. And then I
Well,
created a
okay.
point right there, shot it, accurate to within, I think it was a half an inch, maybe a little bit more. And then I just started scanning,
Okay, so that means that the point clouds would be relative to the coordinate system of the drawing,
Yeah,
and then you're collecting real world data, and now you can see how that real world data matches the rest of your drawing as you start moving through the building.
exactly.
Okay,
And
cool.
so, yeah, so we didn't quite scan the whole building, but we did scan enough in order to be able to create our own control and things like that.
How did you break up the point clouds? Because this building is big, it would have been a lot of scans. So
Yeah.
how'd you do that?
I basically broke it up by, we did a, hallway here, hallway there.
And you
And it was
named them. You
actually,
that that was a that, those were individual jobs. Those hallways.
yes, they were
Okay.
their own projects. And basically we would take them and kind of treat them as their own projects. And then the ones that were touching one another. So I actually didn't have to do these hallways because those were not necessary. It was these outer ones. So basically, we could treat each data hall as its own project, and that's what we did.
Mm.
Um, and so we did some tweaking to make it all fit within the same model. Um, but
Did
all
you?
in
Okay.
all, yeah, but all in all, I went through and I kind of did some scanning around the data hall, got enough control points that I could set up in the middle and really, hit one here on this wall, hit one on this wall, maybe two more on this wall, maybe one over here. Just really, really triangulate my position and things like that.
Hmm.
And so,
Interesting. Okay, I've never heard of anybody taking this approach before, but it's just because of my newness. I think you're using the plan set to create control, then capturing real world data, and then using that in small bite-sized chunks to actually figure out where the walls are, so that on your design you
mhm,
can hit where you need to hit in these little in the interior of these walls. So
yeah. So what we
kind of
did
cool.
was, yeah, that ClearLink software was able to, uh, it enabled us to generate, a more accurate architectural model. And so basically, our VDC department modeled everything and used those as a constraint. And then we didn't really need to change much going on in here. It wasn't drastic enough, but we just needed to be aware of the tolerance that we had.
Hmm.
I mean, I think we found that this wall actually was almost half a foot off, um, which is quite a lot.
Hmm.
But it was all accounted for, and it was all made clear as far as we went through the construction process. So
Well, if the wall's off by a half a foot relative to your design, you find out what that is actually in the real world from your scans. I mean, that would make a dramatic impact on your layout. To be able to nail those
and
walls. So
and
that's awesome.
luckily it actually didn't too badly. I mean, once we were able to submit some drawings and let the GC know, hey, this is
Yeah.
in the wrong spot. I mean, like I said, we use those as constraints with our design,
Hmm.
with our virtual design team, and
Yeah.
and so they were able to make it work and make it so that it wouldn't have been a huge issue. And that's part of that is, I give a lot of credit to the GC for allowing us to really take this project by the horns and run with it. So
Yeah, just that data capture process. identified this problem, so you were able to be, in front of it on your design. So that's awesome. It's a unique way to, um, capture data relative to what the design is. So that was, I'm really glad that you brought just that particular approach that you took on that particular job, because I think that is something that maybe a lot of people haven't considered, especially when it comes to scanners. So definitely a lot of people doing as-built measurements, and then bringing that, but to bring LiDAR data in is, I think that was a new concept to me. So